So GCF is one of those things that you'll eventually want to be able to do in your head, but I've got a couple strategies for you if the numbers are really big or you just want to check your mental math, because making sure you have the greatest common factor is really important. So the old way of doing it is like I did in the previous slides, was listing out every single number that goes into that number, comparing them, finding the biggest one, and it's just really time consuming. So what I found is upside down birthday cake method or upside down division is really just a whole lot quicker, and it's going to help us later on, and you'll see more about that later. So let's start with this one. Let's find the GCF of 28x squared and 48x. Now eventually that word and is going to be replaced with a plus or minus sign, but for today we're not going to worry about that. So what I'm going to do is I'm going to take 28 and 48 and I'm going to do upside down division. So I'm going to think in my mind, what number can go into both of these numbers evenly? Well, here's the cool news. They're even. 28 is an even number, 48 is an even number. Anytime you have even numbers, you can always start with 2. If you're really good at your multiplication and division, you may recognize a number bigger than 2, and you're welcome to use that number. This is just a strategy to fall back on if you start out struggling. So even number, let's start out with a 2. So 28 divided by 2 is 14. So I'm going to write that right there. 28 divided by 2 is 14. 48 divided by 2 is 24. Those numbers are still even. So what I'm going to do is I'm going to create another upside down division. And the joke is, if you cover this up, it looks like an upside down tiered birthday cake, like half of a birthday cake. So that's why it's called the upside down birthday cake method. But these are still even. So I'm going to go with 2 again. So 14 divided by 2 is 7, which is a prime number. So that's kind of a hint that I might be at a stopping point. 24 divided by 2 is 12. So like I said, 7 is prime. It's also odd, so 2 is not going to work anymore. So anytime you have a prime number, the only thing that goes into a prime number is a prime number. So the only option I have if I wanted to do another tier would be 7. Now 7 divided by 7 is 1, but 12 divided by 7 would be a decimal. And you don't want decimals, you only want whole numbers. So at that point, I can stop. I'm done. Taking it down to 7 and 12 is as far as I can go. So what I'm going to do to get my GCF, I'm going to take those numbers I divided out, the 2 and the 2, and I'm going to multiply those. So 2 times 2 is 4. So the greatest common factor of those two numbers is 4. Now you may have been sitting there thinking the whole time, Miss Bowling, 4 goes into 28 and 48. Why did you not start with 4? Which I could have absolutely done. Watch what would have happened if I had started with 4. I'm going to skip the calculator work this time. 28 divided by 4 is 7, which is exactly what I got. 48 divided by 4 is 12, which is exactly what I got. Okay. Either way, whether you divide out 2 twice or 4 once, the greatest common factor is 4, and you get down to the 7 and 12 either way. So there's multiple ways to get to the same spot. Okay. Now variables, here's where it becomes a little bit different. So x squared, I'm going to do the expanding method. This is called the expanding method. I'm going to write out x times x, right? Then 48x, well, that's just 1. So now what I'm going to do is I'm going to circle variables they have in common until I can't circle anymore. So this first term has an x. The second term also has an x. So they have this x in common. I'm going to write it down. Now this term has a second x, but this term does not. So they do not share a second x in common. They only have 1 in common. So I'm only going to do this once. So 2 times 2 is 4 times x is x. That is my greatest common factor. The biggest thing that goes into both of those is 4x, okay? Now, the variables might still be a little touchy, but we're going to do some more examples and we'll get those, I promise.